Today I'm going to do a video about CH2CO12, which is called dichloromethane. Dichloromethane is a liquid at room temperature and it has boiling point 39.8 Celsius to 40 Celsius. Melting point is negative 97 Celsius, which is negative 142.1 Fahrenheit and 176.5 Kelvin. CH2CO12 is a solvent. It is non-flammable, sweet, and it has pleasant smells. So let's talk about the Lewis structure of dichloromethane. This is the valence electron calculation of dichloromethane. C is for plus 1. 1 is hydrogen, but it has 2 atoms when multiplies by 2. The same with chloride. So we have 4 plus 2 times 1 plus 12 times 7 equal 20. So here's the Lewis structure of the CH2CO12. C has the least negativities, so it has to be in the middle. And here's the 3D shape of dichloromethane. So let's count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 16, 18, 20. H can't have more than 2 electrons, so it doesn't have any extra electrons. This is tetrahedral because it has 4 atoms around the central atom and it doesn't have any lone pair. The bond angle of it is 109.5 degrees and a hybridization is sp3. So let's talk about the polarity of bonds. This is the electronegativity value of CH and Cl. C is 2.5, H is 2.1, Cl is 3.0. So Cl has the stronger electronegativity than C, so it's pull the electron from the C. So it's half less 0.5. So C has the stronger pull than H, so it's pull electron from H to C. So it's 0.4. The bonds of H and C is non-polar because it's less than 0.5. The bond of Cl and C is polar because it's equal to 0.5. So overall, the polarity of bonds is polar because the pull of Cl is stronger. It has the biggest electronegativity value. So the polarity of the whole molecule is polar because it's unequal sharing electrons. It has different atoms around it. So let's talk about the phase diagram of the dichloromethane. So this is the solid, liquid, gas. The triple point at negative 106.9 degrees. The pressure is 0.131 atm. This is the triple point, and the normal melting point is at 1 atm and at negative 97 degrees. The boiling point is the same. It has the same pressure, 1 atm and 40 degrees. So the melting is from solid to liquid, freezing is from liquid to solid, sublimation from liquid to gas, gas to solid is deposition. Vaporization is from liquid to gas, and condensation from gas to liquid. So the condition of my molecule to be a liquid is at 20 degrees and 0.8 atm. So if I want my molecule from solid to gas without changing the temperature, so I have to moving down. The temperature has to be the same, so I have to moving down. If I want my compounds to change from liquid to solid without changing the pressure, it has to be staying here, and then we move backward. It needs to change the temperature. So And then this is the molecule of the dichloromethane. So let's talk about the heating curve. Moving on the heating curve of dichloromethane. This is solid phase, liquid phase, gas phase. This is the average kinetic energy, and this is the average potential energy. So from solid to liquid melting, liquid to solid freezing, condensation is from gas to liquid, vaporization is from liquid to gas, and same with phase diagram. Sublimation is from solid to gas, and deposition is from gas to solid. And the melting point is as negative 97 degree. So this is the melting point and freezing point. For the boiling point, it has to be 40 degree. So this is the boiling and condensing point. This is how the dichloromethane is supposed to look like when it's at solid phase. So it's connect together because chloride has the negative charge and hydrogen have the positive charge, so it's attract each other. So when we move to liquid, it is spread out across because the IMF is weakened. So it's supposed to look like this. So when we move from liquid to gas, the IMF has to be broken. So all the things needs to be apart from each other. And it's moving around the container like this. So this is how it looks like in solid phase. And this is how it looks like in liquid phase. And this is how it looks like in gas phase. Thank you.